Yeah, so this question comes. It says that write half reaction at A. Okay. So how do we identify A? Okay, you go to the battery, and from the battery it's very clear that it's the positive which is attached to A. So that makes A to be positive. So the question is, what do we call a positive terminal or positive electrode? It is anode. So the positive electrode is anode. And what reaction occurs at anode? It is oxidation. So this is what you have to know, that inside the electrolyte, we have two ions. We have copper 2 ions and chloride 2 ions. And according to mechanism of conduction, the negative ions move to the positive electrode. And the positive ions move to the negative electrode. So for A, the ions which are coming to A are chloride ions. Okay. So what happens to chloride ions when they come to A? Okay. They undergo oxidation. So they turn into chlorine gas. So before you proceed with this one, what do? You have to ensure that this one is balanced. So you put 2 to make sure that it's balanced. Now, putting a 2 here makes the negative to be 2. And negative implies electrons. So it means that we are having 2 electrons to deal with here. And that is it. So what you have here is the reaction which takes place at A. This is aqueous and this is gaseous. Yeah. Now we come to this one. It says that write half reaction at B. Okay. So when you look at B, this is our B. B is attached to the negative part of the battery. So implying that B is negative. And what do we call a negative electrode? A negative electrode is called cathode. So B is cathode. And what reaction occurs at cathode? It is reduction. So what is going to happen here? We're having our copper ions moving to B. And they are going to undergo reduction, implying that they are going to change into copper solid. So in this case, how do you balance this reaction? Because remember, the 2 sides have to balance by putting 2 electrons here. So this is the half reaction which takes place at B, which is cathode. Yeah, then we come to this one. It says that write the net redox reaction for the cell. Okay, we need to know that the net redox reaction is the sum of the reaction at anode plus the sum of the reaction at cathode. The sum of the 2 is what we call the net. And what do we do here? So we add these 2. In adding them, this is what you have to know. That the electrons here, the number is the same as this one, so they cancel out. And after cancelling out, you write what is remaining. So we are having 2 chloride ions here, plus copper ions. Okay. Then taking us to the product side, what do you have that side? It's chlorine gas, plus copper solid. So what you have here is the net redox reaction. Yeah, then we come to this question. It says that write 2 observable changes at B. Yes, this is our B which is cathode. So to answer this question, what do you do? We need to look at the equation which took place at B. Okay, what did we see at B? We saw that copper 2 ions became reduced to copper solid. Okay. So now you need to know that every time you have a solid as the product, it implies that the mass of the electrode you are dealing with increases. So the first observation is that mass of B increases. Yes, because you have this one as a solid. Okay, second observation is also related to this. Second observation is that we are seeing copper, this copper solid forming there. And copper solid is brown in color. So what are we going to say? A brown solid is deposited on B. So that is that. So brown solid is deposited on B, and B increases in mass. Yeah, then we come to this one. It says that write one observable change at A. So this is our A. So how do you proceed with this? The first step is to identify the type of reaction taking place at A. So we realize that chloride ions came at A, and it became oxidized to chlorine gas. To proceed with this, you have to make this one balanced. So we have 2 electrons involved. This is the reaction which took place at A. It's an oxidation reaction. And we have to know that this is gaseous in nature. And that's the observation. So what's the observation? This gas forms at A. But now you need to know, what is the nature of chlorine? Chlorine is greenish yellow gas. So what are you going to say? We're going to say greenish yellow gas forms at A. Yeah, then we come to this question. It says that by use of arrows, show the direction of flow of electrons. Okay, on the circuit here, how do electrons flow? Okay, here I need to tell you that electrons in electrolytic cell, they move or they flow from anode to cathode. During our times, we used to say from A to C for easy recalling, because A comes before C, so it's easy to recall. So the question is, which one is anode? Anode is the positive one, so this is the positive, and this is the negative. So how are we going to show the flow of electrons? We said from anode to cathode, so it's going to be in this direction. Yeah, then we come to this question. It says that state and explain the observable changes in color of electrolyte as the cell operates for some time. So how will it change? So what changes are we going to observe here? Okay, to answer this question, you need to look at the net reaction. We have realized that 2 reactions are taking place here. First of all, we said chloride ions became oxidized to chlorine gas. Okay. Secondly, what did we say? We said the copper ions became reduced to copper solid. Okay, this gave us the net reaction, which is 2 chloride ions plus copper 2 ions, giving us chlorine gas plus copper solid. Yes, this is the net, and our answer about how the electrolyte will change comes from this net. Okay, what do you have to observe about the net? You have to know that copper 2 chloride is blue in color. It's a blue solution. And that blue solution is caused by the presence of these ions. These ions are blue, which ions? Copper 2 ions. And they are busy being converted into this. This one is copper solid, but it's not even in the solution. It's deposited. So in other words, it's like you are taking out blue and depositing it somewhere and not even in the solution. In other words, it's like you are busy taking out the blue from the solution. So what is happening? The solution is losing the blue color gradually as the cell operates. Why? Because copper 2 ions, which are responsible for the blue color, are being reduced to copper solid. Yeah, that is that. Yeah, then we come to this one. It says that state any 3 changes which can lead to the speeding up of the process in the cell above. So what can we change here to make this process become faster? Okay, first, we can increase the temperature of the mixture or of the electrolyte. Yeah, that's that. Secondly, we can increase the concentration of the electrolyte. Yeah, that is that. Then thirdly, we can increase the voltage or EMF of the cell. Yes. So these are the 3 ways of increasing the speed or speeding up. So these are the 3 ways of speeding up the process above. So that is that. And with that, I would like to say thank you for your time. We urge you to subscribe, to comment, to share, to like. Yes, we believe we are simply the best. So stick with us. You won't regret. I'll see you next time. Bye bye.